Hello. Okay, I guess everybody's here that's going to be here. Ben's here twice. He's special. So we're going to try doing class online. So what I'm going to do is basically just I've typed up some of the stuff so I didn't have to write it all out. Some of it I'm just going to handwrite, and then what it's going to be probably is we'll try to get through as much of a section as we can in a day. If we finish a section, if there's any extra problems I want to do, I'll make a second little video, and then I'll give you all access to a YouTube channel, and it'll have the original lecture here, and then it'll also have the extra video if I make any for that section, whatever we're covering that day. Since this is the last section, 9.4, that's going to basically be the end of the stuff for this test. And I think the test, what we'll do is we'll do that on Thursday. Since it's normal class time, as 1, we can do that. Anybody have objections to Thursday at 1 for the test? Ben does. Oh, or you accept it, okay.
On the right side. Oh my gosh, you unmuted yourself. Oh, it's me.
How about you, Ashley?
Good.
Good?
Yeah.
All right. Whitney?
Sounds fine to me.
All right.
That works for me.
Okay, did you get to go to Hawaii?
I did, and I made it back before they closed the borders.
I was wondering.
Yep. Yep, I am back in Casper.
Too bad you could have stayed over there for longer. It'd been
I
nice.
know.
All right, so Thursday at 1, we'll do the test. So I've put in a practice quiz, I guess you could call it, in Moodle. So that'll be something that you can do to take to see if you can do the inputting of the different equations, exponents, fractions, whatever in Moodle compared to how we have it now, where we do it on paper and pencil. And I think what I'll have you do is we'll take the test via Zoom so I can watch you take the test. Once you submit everything, what you can do then is if you want me to look at your pages, you can take photos with your phone and then email them to me. And then that way I'll know, you just didn't type the answer wrong or whatever. So I think that'll probably be how we do that. We can talk more about that on that day. Let's see what else is there. Since we won't be taking a test till Thursday, and today we might finish this. I don't know if we will or not, but if we do, or if we finish it tomorrow, we'll probably just go ahead and start on the next section. If you have ever any questions as far as after our 1 o'clock meeting time, if you're like have questions in the morning or afternoon or something, email me and I can answer them. If you want to get on Zoom together, we can get on Zoom and work problems or whatever and do that. So yeah, so it's going to be a learning experience for most people. So if you ever have questions, just let me know, okay? All right, so let's go ahead and get started here. So we're doing, section 4 and chapter 9, which is about partial fractions. So when we are going to do is we're going to start with looking at adding fractions, which is also called the composition of fractions, before we look at the partial fractions, which is actually decomposing the fractions. And so how would we add these two fractions together? So what we would do is we would start with, let me get there we go. We would start by finding the LCD, because to add two fractions, you have to have the least common denominator. So for this case, our LCD is going to be equal to x minus 3 times x plus 2. So that's our least common denominator. So to get that for both of the fractions, what we're going to have to do is we're going to have to multiply this one by x plus 2 over x plus 2. And we'll have to multiply this fraction times x minus 3 over x minus 3. So when we do that, we're going to get one long numerator, and then we'll have the denominator is just going to be x minus 3 times x plus 2. Now, when we take x plus 2 times 2, we're just going to distribute, and we'll get 2x and then plus 4. And here we're going to take and distribute the minus 1 here, so that's going to give us minus x, and then that's going to become plus 3. So now what we can do is simplify. So we have 2x minus x, so that's going to give us x. 4 plus 3 is 7. And if we go ahead and FOIL this out, we're going to have x squared, and then we'll have a minus 3 and then plus 2, so it's going to be minus x, and that's going to be minus 6. And so then that gives us what we get with adding those two fractions together. We get x plus 7 over x squared minus x minus 6. Okay, so we've done that kind of thing, you know, whether it's just fractions 1/4 plus 3/9 or whatever it is, we've done stuff like that. And so we should know how to do this. Now what we're going to do is we're going to kind of go the opposite way. We're going to do partial fraction decomposition. It's basically, like I said, is the opposite of what we just did. When we added the two fractions, we're going to end up with the answer, and then we're going to go backwards and get what the two fractions added together were. And so the first one we're going to do is here with the non-repeated fractions. And so we're going to have like, I think 4, maybe 5, I can't remember off the top of my head. We're going to have different cases. So this one's going to be for non-repeated fractions. So what we want to do is we're going to have some p of x over q of x, and we're going to factor our q of x, the denominator, and we're going to factor it into whatever we can do. And in each case, some of them we're going to have something simple. It might be just x plus 2 times x minus 3. Sometimes it might be x plus 2, the quantity squared. Sometimes it might just be a trinomial and be a quadratic. So this time what we're going to do is we're going to end up with something like non-repeated factors. So it's kind of like what we just had as far as our initial addition. So once we factor it, then we're going to use the variables a, b, and c as needed for the number of factors of q and x. So in this case, if we had two factors, the x minus 3 and x plus 2, we would just have a and b. But if we had 3 or 4 up to, you know, z factors, we could go out as far as we would have. What we're going to do is we're going to take our q of x, whatever it was factored, we're going to put a over one of the factors, then plus b over the other factor, and then plus c over another factor if we have more, until we get all the factors done. And then what we're going to do is we're going to take that whole equation, multiply both sides by the least common denominator, and that's going to get rid of all the fractions. Then we're going to multiply everything out on the right side. So because we're going to have, you know, an a times some a2x plus b2, and we're going to have a b times a1x plus b1, and we're going to multiply all that out. And then what we're going to do is we're going to set the coefficients of like terms on the left side to the coefficients on the right side. So if we have x squared on the left, whatever its coefficient is, we'll look for all the x squareds on the right and have those coefficients, and we'll set those equal. And you'll see what I'm talking about here in a little bit. And then once we do that, then we're going to end up with a system of equations that we actually have to solve. And so this is the key thing, is really this part here. For non-repeated factors, we're going to have a over the a1x plus b1 plus b over a2x plus b2, and that's going to be our format. And so that's what we're going to work with. Later we're going to have different things. We're going to have maybe this one's to the 1 power, and this one's to the 2nd power, and this is to the 26th power. There's going to be all kinds of different forms that we're going to have depending on what it is: non-repeated factors, you know, irreducible quadratics, things like that. So let's say this is our first example. So it's similar to our first one, but we have an x minus 3 and x minus 2 instead of the plus 2 here. And what we want to do is we want to get it back to what two fractions did we add together to get to it, okay? So what we have is, it's nicely done. We already have the two factors. We have x minus 3 and x minus 2, so that part's done. We didn't have to do any factoring. And now what we're going to do is we're going to basically set the x minus 3, we're going to put a over that. And then x minus 2, we're going to have b on top of that for the numerator. And so what we're going to do is we're going to rewrite this as, let's write it over here, x over x minus 3 times x minus 2. And that's going to be equal to a over, and then we do the first one, x minus 3, plus b over the second one, x minus 2. That's our first step. And so that's what we do for this part here, part 2, I guess. We did the factoring already. It was already done, so we didn't have to do it. And so now what we've done is we've taken a over the first factor plus b over the second factor, okay? Now what we want to do is we want to find the LCD. Well, the LCD is going to be our original, whatever our factors were over here. So we're going to take that whole thing times our LCD of x minus 3 times x minus 2. And so we're going to take that times each thing. So we're going to distribute, you know, here, we're going to distribute here, and we're going to distribute here. Well, when we take it times the first one, everything cancels. And so we're just left with x on the left side. Now, when we take it here, the x minus 3 cancels x minus 3, and so we have a times x minus 2. Then plus, now we have b times, well, now the x minus 2's cancel, and we're left with x minus 3 here. Okay. Now what we need to do is the next step, which is basically we're going to expand the right side and add like terms. So now we're going to expand this. And so we're basically going to distribute our a times x and a times the negative 2. We're going to take b times x and b times negative 3. So we get x equals ax minus 2a plus bx minus 3b. All right. So now what we're going to do is we're going to set the coefficients of the terms on the left equal to the coefficients on the terms on the right. So here, this coefficient is basically just a 1. And so we're going to set all the terms on the left which have x, we're going to say that's going to be equal to, let's put it over here, maybe 1 equals, now here we have an x, so we're going to have a, and we also have an x here, so that's going to be plus b. Okay. Now, we don't have anything else over here for just the numbers. So, you know, if we had a normal quadratic or even whatever number, you usually have, you know, x squared plus x plus some number 2. And so this is what we have here. We basically have 0x squared. And this really is 0 because there's nothing else over here. There's just x. And so then we're going to set our 0 in this case equal to, and then we have the coefficients of just the numbers. Well, that's going to be a minus 2a, and then we also have a minus 3b. So then that's going to be minus 2a, and then minus 3b. And now we set the coefficients of the terms on the left equal to the coefficients on the terms on the right. So now we have two equations. 1 equals a plus b, and 0 equals minus 2a minus 3b. And now we need to solve that system of equations. And so if I look at this, I see we can multiply this term or this equation by 2, and then I'll have a positive 2a. And if I add it to this, that will cancel. Or we can multiply this one by 3, and we'd have a 3b, and then minus 3b, that would get rid of the b's, and we solve for a's. So depending on if you want to solve for a's or b's, we can do it either way. I think I'll just multiply this by 2 and then add it to this equation here. So 2 times 1 is 2, 2 times a is 2a, 2 times b is 2b. Add that together. So now I'm adding the two equations together. So 0 plus 2 is 2 equals, well, now those cancel, and then I'm left with minus 3b plus 2b, so it's going to be a minus b, or b equals a minus 2 if I solve for b, because I'll divide by a negative, and that gives me b equals 2, or negative 2, sorry. Now I could plug that negative 2 back into the original equation here, or I could plug it into here. This one looks a little easier, so that tells me, okay, 1 equals a minus 2, so add 2 to both sides of the equation, and 3 is equal to a. So I have a is 3 and b is minus 2. Now what I'm going to do is I'm going to take that and plug it back into our original spread apart two factors here. And so I have on the left one, a, well, that's 3. So I have 3 over x minus 3 plus b, which was a negative 2 over x minus 2. And that then is what our original equation is. If we added these two fractions together, we're going to get this x over x minus 3 times x minus 2. And so that would be our final answer as far as we decomposed our original fraction that was given into these two fractions that are added together. Now, one key thing, you could have said, okay, this is a minus and then just put a plus 2 here, but I just put a plus and put the negative 2 in the numerator here. Okay, so that's one example. Let's look and see. I think I have two. Now this one, basically what we have to do is we have to first factor that denominator. After we factor the denominator, then we can start breaking it apart. So if we think about what is x squared plus 10x plus 24, well, if I have factors of 6 and 4, that will add to 10. So then that's going to be equal to x plus 6 times x plus 4. Okay. Now, it doesn't matter which one we say is first, which one is second. If we want to go, you know, bigger or smaller first and then bigger, we can do that. And it really doesn't matter. What's going to happen is whatever you do for A and B, it's going to work out correctly in the end. So what we're going to do is we're going to take this and rewrite it as 5x plus 16 over, then we have x plus 4 times x plus 6. And then we're going to factor that into A over our first one, which is x plus 4 plus B over x plus 6. And so now we've got our two fractions that we're going to solve for. And once we get A and B, then we'll be like the last one. We'll have what two fractions are equal to. So now what we have to do is we have to multiply by our LCD, which basically is just what's on the left here. And so we're going to multiply both sides by x plus 4 times x plus 6. And so again, we're going to multiply all three terms by that. When we multiply the first one, we just get 5x plus 16. Now here, notice we have the coefficient in front of the x is 5 now instead of the other one had 1. We actually have a number here instead of the other one was 0. So it's going to be a little bit different this time. Now when we multiply the a over x plus 4 times this, the x plus 4's cancel. So what we're going to get is we're going to have a times x plus 6 plus, now when we multiply this, the x plus 6 is cancel, and we're going to get b times x plus 4. Now we have to simplify, so that's 5x plus 16 equals, now we have ax plus 6a plus, now we have bx plus 4b. Okay. Now we're going to set and make our system of equations. We're going to have x's, and we're going to have numbers. And so that's going to be our two equations. So we're going to have 5 equals, then we just have a plus b, because again, we just take the coefficients in front of the x. And our second equation is going to be 16 equals, then we have 6a plus 4b. Okay. So now we have to solve this system of equations. I think what I'm going to do is I see if I multiply the numerator or the first equation by a -4, when I add it to that, the b's will be gone and I'll be left with a, and then I can go back in and substitute and solve for b. So I'm going to multiply this one by a -4. So if I write that to the side, that's going to give us a -20 equals a -4a minus 4b. And this one still is 16 equals 16, or oops, not 16a, just 6a. All right, so 6a plus 4b. So now when I add those together, our 4b's cancel, which is what we wanted. So I have a -20 plus 16, so it's going to give us a -4 equals. Here we have 6 minus 4, that's 2a. So if I divide by 2, a is equal to a -2. All right, so that's what a is. Now I can plug that back into our first equation. It looks like that'll be the simplest, and so I'll have 5 equals a -2 plus b. So if I add 2 to both sides, b is equal to 7. So I've got a is -2, b is 7. So back in our original equation, now I have to plug in a is -2, b is 7, and so I'll get the final thing of -2 over x plus 4 plus 7 over x plus 6. And so then that would be my decomposition of the original fraction here that was given. Okay. Now this is how it works when we can factor and get two nice factors. We just have the a over one factor plus b over the second factor. So those are the nice kinds. Then from there, sometimes can get more complicated. And what we'll do is we'll go to the next one, which is we have repeated factors. All right, and so instead of just saying we had maybe x plus 4 times x plus 6, maybe we had x plus 4 times x plus 4. Okay, So what we have to do is, just like last time, we have to factor our QX to know what our factors are, unless they give it to us already, which is sometimes the case. And then what we have to do is we're going to take A over one of the factors, the AX plus B. And then depending on how many repeated factors there are, if there's just two, then we'll have B over the AX plus B, the quantity squared. But if, say, for instance, you had, some X plus 2 over X minus 4, the quantity to the fourth, what's going to happen is we're going to have an A over the X minus 4 plus B over X minus 4 squared plus C over X minus 4 to the third plus D over X minus 4 to the fourth. And so depending on what your value here is for the exponent depends on how many of these A, B, C, D, all the way up to Z. Hopefully you won't have that many, but that would be the case. However many you have is going to be however many A, B, C's and stuff you have. Then the rest of the thing is just the same. So the key difference in all of these really is this step here. What is going on? And so this one is with repeated factors. So after we find our A over and B over, we'll multiply both sides of the equation by the LCD again to eliminate all the fractions. Then we're going to expand the right side. We're going to set the coefficients of the left side equal to the coefficients of the right side, get our system of equations, solve them, and then we can rewrite our final thing with whatever A was over our values plus whatever B was over their values, and so on until we're done. All right, so let's look at this example. Now this one's, again, factored nicely. So, what usually happens is they factor one nicely, the next one you have to factor on your own. All right, so let's do this one. And so this, if we rewrite this, that's going to give us A over X minus 1. And if we want to go ahead and put it in parentheses, we can. And then the next one's going to be B over, and it's going to be X minus 1, the quantity squared. And so that's kind of what it's going to look like here. We have A over the X minus 1 plus B over X minus 1, the quantity squared. That was the highest degree, and so that's as far as we have to go now. All right, so now what we have to do is we have to multiply both sides of our equation by the LCD, which is just the X minus 1, the quantity squared. So if we take this whole thing times X minus 1, the quantity squared, we get on the left, when you take that times that, the X minus 1 quantity squared goes away, and we get 6X minus 11. Now, when we take this times this, one of the X minus 1's are gone, so we're going to have A times X minus 1 plus, now on this one, all of them cancel, and we just have plus B. Okay. Now we have to expand here, so that gives us 6X minus 11 equals AX minus A plus B. Okay. Now here, the AX and the 6 go together, and the minus 11 and the minus A plus B go together. Okay. So our two equations are going to be, the first one is just going to say A equals 6. And that's all we have. It's just A equals 6, and we've got A already. So we know what A is. So now we just have to solve for B. Well, the other one is a minus.
Hey, Barry, it looks like you stopped talking.
Okay, I'm back again. I don't know what happened. I got kicked out. That's the bad thing about the live meetings. So hopefully they'll continue working. All right, so let's go back to where we were, which was right here. And so we had the 6 over the x minus 1 and the minus 5 over the x minus 1 squared. So again, if you wanted to put a minus here and just put a positive 5 here, that would be fine. All right, so the next thing we can do is one where we actually have to factor. Now this one, I notice right away that if we have 2x squared plus 12x plus 18, I can factor out a 2. And then that gives me x squared plus 6x plus 9. And this one is going to give me x plus 3, the quantity squared. And so that gives me 2 times x plus 3, the quantity squared. Okay. So now what we have is, if we write it all out, we have the 5x plus 14 over 2 times x plus 3, the quantity squared. And so that gives us a over 2 times x plus 3 plus b over 2 times x plus 3, the quantity squared. Okay. Now our LCD is just the 2 times x plus 3, the quantity squared. So I'm just going to multiply by that, 2 times x plus 3, the quantity squared. And when I do the first one, we just get 5x plus 14. Do the next one, we're going to have a times x plus 3. And then the next one, everything cancels. We just have b. Now multiplying everything out, that gives me 5x plus 14 equals ax plus 3a. And then I still have plus b. So my 5x and a go together. My 14 and the 3a plus b go together. So I have a equals 5 and 14 equals 3a plus b. Well, I know a is 5, so I can solve this one. So 14 equals 3 times 5 plus b. So if I subtract 15 from both sides, I get b equals a -1. All right, so plugging everything in, a and b, into our equations up here, we get 5 over 2 times x plus 3. And then we have plus, and again, you could put a minus and then put a positive 1 up here, but either way, it doesn't work, doesn't matter. X plus 3, our quantity squared. And then that would be our original fraction decomposed into 2 fractions. All right, so let's go on to the next one. That's just going to be a different kind of fractions that we're going to have to decompose. And these have non-repeated, irreducible quadratic factors. And so they're going to be something like, ax squared plus bx plus c. And so depending on if we end up with the factor we can pull out in front that's just ax plus b, or if they're always just going to be some a1 x squared plus b1x plus c1, and then times another quadratic, depends on how we have it. And so we're going to have a over this if we just have the plain old ax plus b. And then we'll have a bx plus c over the first quadratic plus dx plus c over the next quadratic, and so on. And again, same thing works for 3, 4, and 5. It's just the key now is we have to separate it like this. And so once you factor that q of x, it will depend on what your final equation is going to look like. So this one here, we have the x minus 1, and so that's going to be our a over x minus 1. Oops. Then we have an x squared plus 1, so that's going to be this part here, and so that's going to give us a bx plus c, and we don't have any other terms after that, and so that's all we're going to have is the a over the first term plus bx plus c over the second term, and then we have to simplify from there. So if we do that, let's say we have then a over x minus 1 plus, now remember it's bx plus c over our x squared plus 1, okay? And that's what we have to get after for second step. So that's our step 2, that's what we end up with. And now the rest of it's the same. We multiply all the whole equation by our LCD, which is x minus 1 times x squared plus 1. When we do that, the first term, everything on the denominator cancels, and we get 5x squared minus 6x plus 7. Now here the x minus 1's cancel, so we have a times x squared plus 1 plus, now here the x squared plus 1 cancels, so we'll have bx plus c times x minus 1. Okay. So we have a little bit more to do here. We're going to have to FOIL this side, and then we just distribute here. So if we rewrite our left side, 5x squared minus 6x plus 7 equals, now that's going to give us ax squared plus a plus, now that's going to give us bx squared. That's going to be minus bx. That's going to be plus cx. That's going to be minus c. Okay. So x squared, well, we have that one, we have that one, and we have that one. Then we have x's, and then we have x's, and we have x's. And then we have the number, and we have this number, and we have this number. So we're going to have 3 equations, 3 unknowns. So our first one is going to give us 5 equals a plus b. Our next one's going to give us minus 6 equals, and then over here we have a minus b plus c. And our last one's going to say 7 equals, and then we have a minus c. All right, so what do we want to do here? Well, there's a lot of things. I think what I see just right off is if I add those 2 equations together, I get rid of the b's. And then I notice if I take that resulting equation, I'm going to have a c, and if I add it to the last equation, the c's will cancel. And so I think that's kind of the route I'm going to go here. First add those 2 together. So if I write plus, then I'm going to have 5 equals a plus b minus 6 equals minus b plus c. When I add those together, that cancels that. Here I have a minus 1 equals a plus c. Now I'm going to add to that. So I have 7 equals a minus c. I'm going to add minus 1 equals a plus c. So now those cancel. And here I have 7 minus 1 is 6. A plus a is 2a. So divide by 2. So a equals 3. So I have a. I can plug that into this one or this one. Or I can plug it into whatever I want to get either A or B, depending on how I want to do it. If I plug it into this one, we have 5 equals 3 plus B. Subtract 3. B equals 2. Now, if I plugged it into, let's do it in this one here so we can get a positive C. We have a minus 1 equals 3 plus C minus 3 minus 4 equals C. All right, so I've got C, I've got A and B. So now I can plug that into my original items up here. And since I'm out of room at the bottom, let's do it here. So A was 3 over x minus 1 plus B, which was 2x. Then C is minus 4, so minus 4 over x squared plus 1. And so that then would be my decomposed a fraction from that. Okay. And again, the key difference is if you have to factor it, then it's going to be a little harder. If you don't have to, then you just have to put the a over any term that's not got a square, and then the bx plus c over whatever term has a quadratic on the bottom. And if you have no single terms like x to the first, then you won't have any a's. It'll just start out with the bx plus c over the first quadratic plus the dx plus d over the second quadratic, and so on. Okay, so that's that one. Let's look at the next one. Oh yes, the next one. So now we have to kind of remember how to do the sum and difference of cubes, because that's going to be how we're going to get a lot of these factors. And so when we have the sum of cubes, it might be x cubed plus, I don't know, 125, or x cubed plus 27. So you're going to have things that you're going to be able to take the cube root of and get an actual number and get our a value. And so when you do, maybe you know, like if we had x cubed plus 8, well, 8 is equal to 2 times 2 times 2, which is 2 cubed. And so then a then is equal to 2. Okay, so then we'd have x plus 2 times the quantity x squared minus 2x plus 2 squared, which is 4. Now, if it had been, say, x cubed minus 8 instead, then again, a is 2, so we'd have x minus 2 times the quantity x squared, and then we'd have plus 2a, or 2x rather, and then plus 4. Okay, so the key difference is if you have a plus on the sum of cubes, you have a plus on the a plus x, and then you have the negative in the middle. And if you have a negative here, you have a negative here, and a positive here. So those are the key differences. Okay, so our first one is going to be the sum of cubes with the 8. So that one, basically, we're going to do what we did here. We're just going to have the 8 is 2 cubed, and so we just have to plug everything into that formula, and we'll have our denominator factored. And so if we do that, x cubed plus 8, that's going to be equal to, I'm going to have then the x plus 2 times x squared minus 2x plus 4. And so that is the factored form of that. And so if we write that in the denominator, x plus 2x squared minus 2x plus 4. All right, so now we're going to, again, do kind of like we did before. And don't forget what we did was we had a over the non-quadratic part, and then bx plus c over the quadratic part. So we have then a over the non-quadratic part, which is the x plus 2, plus the bx plus c over the quadratic part, which was the x squared minus 2x plus 4. So that's going to be how we split it apart. And now we just do like we've been doing. Multiply both sides by the LCD and then simplify and get our different equations and different unknowns. So it should probably be 3 equations and 3 unknowns when we get done. So x plus 2 times x squared minus 2x plus 4. Multiplying the first one, everything in the denominator cancels, and we get a minus 5x squared plus 18x minus 4 equals. Now here the x plus 2 rather cancel, and we get a times, and then x squared minus 2x plus 4 plus, now we have bx plus c times, well, those cancel and we have x plus 2. Now the left side stays the same, minus 5x squared plus 18x, and then minus 4 equals, now we just distribute here, and that's ax squared minus 2ax plus 4a plus, now we have bx times x, so it's going to be bx squared, then bx times 2, so it's going to be plus 2bx, and then c times x plus cx, and c times 2 plus 2c. So now x squared, x squared, x squared, then we have x, 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 and then we have the 4, that 4a, and the 2c. So our equations then are going to be minus 5 equals a plus b. Then we have 18 equals, and that's going to give us a minus 2a, and then plus 2b, and then plus c. And the final one's going to be a minus 4 equals, and then we have our 4a, and then plus 2c. Where'd my a go? Too far down, I keep hitting the thing here. All right, so 4 is 4a, then plus 2c. All right, so now we've got 3 equations, 3 unknowns. And so how are we going to solve this? Well, if we look at this, it's going to look, I think we're going to do this similarly to the last one. I think if we take and somehow add these two together and make it so that either the B, I think the B's disappear. I think that'd be a good thing. We'll be left with A's and C's. Then our last equation only has A's and C's, so then we could eliminate something again. So that's my plan. So I think what I'm going to do is I'm going to take this one times maybe a -2. And so if I do that, that's going to give me 10 equals a -2a minus 2b. And then if I take that plus 18 equals -2a plus 2b plus c, then we get 10 plus 18 is 28 equals, now that's going to be a -4a, those cancel, plus c. Now if I take it and add it to that one, then I get 28 equals -4a plus c, and -4 equals 4a plus 2c. And so here I get 28 minus 4 is 24 equals, now those cancel, and that's going to be 3c divided by 3, then c equals, oh yeah, 8. Okay, so that gives me c. Now I can go back in and solve for a, either in that equation or that equation. And so if we do it maybe in the, I don't care, it doesn't matter. Let's do it in this one. So we just have the 1c, we have to plug it in. So that gives us 20a equals -4a plus 8, subtract 8. So 20 equals a -4a, divided by -4. A equals a -5. Okay, so if a equals -5, now I can solve for b, and so then -5 equals a, and then minus, oops, that's the wrong thing, a is 5. All right, so then a was the -5, and then plus b. So if I add 5 to both sides, then b equals 0. So I've got B, I've got A, and I've got C, and so now I can plug those all into my two pieces here. So A, I said, was a -5 over x plus 2, plus B, well, B is 0, so I just have C, which is going to be 8 over x squared minus 2x plus 4. Okay, and so then that would be my original fraction decomposed into the original two fractions they added together to get to that final fraction. All right, the next one is just going to be something similar, but what we're going to have is repeated irreducible quadratic factors. So instead of just, the one factor and then some ax plus b, we're going to have that factor repeated several times, 1 to n times, depending on what n was. And so again, basically the difference is we have repeated irreducible quadratic factors, and that's going to be our equation. And so we're going to have some a1x plus b1 over the first one, plus some a2x plus b2 over the second one squared, and so on. Okay, and then the rest of it we do exactly the same. All right, so this one's nice. Again, it's already factored, and we don't have that first a term. All we have is that number, and then basically, so we're going to have this one plus this one. And probably what I'm going to do is I'm going to go ahead and use A, B, C, and D instead of A1, B1, A2, B2. So on this one, I'm going to say this is equal to AX plus B over one factor, x squared minus 2x plus 3, plus, now I'm just going to say CX plus D, just because I don't want to have to worry about the other A1, B1, and so on. And then this is going to be over x squared plus, minus 2x plus 3, the quantity squared. All right, so now I have that. So I'm going to multiply by x squared minus 2x plus 3, the quantity squared. So now I'm multiplying those out. I get that first one is x cubed minus 4x squared plus 9x minus 5 equals. Now one of these is going to cancel one of those. So what I'll have is ax plus, it's just not working there. I'll erase and start over. All right, so that's going to give us ax plus b times x squared minus 2x plus 3. And then plus, now those cancel, so we just get cx plus d. Okay. Now here, we're going to have to distribute. We're going to have to do kind of the rainbow. We're going to take this times each of the terms, and we'll take this times each of the terms. So we're going to end up with 6 terms plus those 2 terms there. So simplifying that, we get x cubed minus 4x squared plus 9x minus 5 equals. Now we take that, and that's going to give us ax to the third minus 2ax squared plus 3ax. Now we take the b's, and that's going to be plus bx squared minus 2bx plus 3b, and then plus cx plus d. All right, so we've got 1x cubed, 1x cubed. We've got that x squared, we've got that x squared, and we've got that x squared. We've got this x, this x, this x, and this x. And then we've got number and a number and a number. And so that should be our 4 equations basically. So 1 is equal to a. So that one is nice. We already have one of our variables. Now here, this one says a minus 4 equals, where's x squared? Okay, that's going to be minus 2a, then plus b. And then here we have a 9 equals, and then we have 3a minus 2b, and then plus c. And then here we have a negative 5 equals, and that's going to be a 3b plus d. And now I'm just going to start plugging in and working my way down, because if I plug that in here, I'll get b. So a minus 4 equals a minus 2 times 1, and then plus b. So that's a minus 2. So if I add 2 to both sides, b is equal to a negative 2. Okay. So now I've got a and b, and now I have to plug it into here and get c. So if I do that, I'll have 9 equals 3 times 1 is 3, minus 2 times a minus 2 is going to be plus 4, and then plus c. So it's going to be subtract 7 from both sides. And so c equals 2. And then our last one, we have a minus 5 equals 3 times b, which was the minus 2, and that's plus d. So that's a minus 6. So if I add 6, d equals 1. Okay. So now what do we have? So now what we need to do is plug everything in here. All right, so let me make sure I have everything. All right, my 3b. Okay, so now we plug a in for that. So a was 1, so we just have x plus b, which was a negative 2. So I should probably just put minus 2 there. So let's do that. All over x squared minus 2x plus 3 plus c, which we said was 2x plus d, which was 1, all over x squared minus 2x plus 3, the quantity squared. Okay. All right, so that is then, I believe, everything that we need there, unless I've messed up somewhere along the way. So, any questions up to this point? All right, so with that then, basically I've finished, oh, I get one more. Oh, never mind, I wasn't finished, but let me finish this one and then we'll be done, and then we can be done with the class as well for today. All right, so it's already factored, so we don't have to worry about that. We have that, and so when we do this, we're gonna get ax plus b over 2x squared plus x plus 14 plus, now we have cx plus d over 2x squared plus x plus 14 squared. And then we multiply all that by 2x squared plus x plus 14, the quantity squared. So doing the same thing we just did on the last one. When we multiply the first one, we drop everything. We just get 2x cubed plus 11x squared plus 7x plus 70 equals. Now one of these cancels one of those, so we get ax plus b times 2x squared plus x plus 14 plus, now all those cancel, so we just get cx plus d. Now we have to distribute, again, a times everything in the numerator, or on the first side, and then b times everything on the other side. So that gives us 2x cubed plus 11x squared plus 7x plus 70 equals. Now we have 2a x to the third, and then plus ax squared plus 14ax plus, now we have 2bx squared plus bx plus 14b plus cx plus d. All right. So now we've got the x cubed. We've got x squared, x squared, x squared. We have a 7x, 14ax, bx, and cx, and 70, and 14b, and d. So it looks like it's going to work out the same way as our last one, as far as all the terms going to be just kind of be simple. So this one says 2 equals 2a. This one says 11 equals, and then we have a plus 2b. And then the next one says 7 equals, and then we have 14a plus b plus c. And our last one, 70 equals 14b plus d. All right. Well, this says then that a equals 1. And so then if we plug that into our second one, 11 equals 1 plus 2b, subtract 1, 10 equals 2b, so b equals 5. Okay. Now we've got a, we've got b, so we can solve this one for c. So then we can say, okay, well, 7 equals 14 times 1 is 14. And then plus b, which was 5, and then plus c. So 14 plus 5 is 19, so we're going to subtract 19. So c then is a minus 12. And here we had b as 5, so what we can do is say 70 equals 14 times 5 plus d. So that's going to be 20, that's going to be 70. So if we subtract 70 from both sides, d equals 0. All right, so we've got a, b, c, and d. So we plug that back into our original equation. So a is 1, so we just get x. B was 5, so plus 5 over 2x squared plus x plus 14 plus c was minus 12x plus d was 0, so we don't have to worry about anything there, over 2x squared plus x plus 14, the quantity squared. And so then those are the two fractions we added together to get to this fraction, or when we decompose this fraction, we get these two fractions here. All right, so I believe then, yeah, that's all I have. So that finishes 9.4. I'll go ahead and do some more videos later with some more examples, and hopefully that'll help you. But again, a lot of it is just remembering, you know, this part here, this is really what's key when you have repeated irreducible or non-repeated irreducible or repeated factors or non-repeated factors. So those are the 4 things you need to kind of remember, and the work going through it isn't that hard. It's just, you know, multiplying the LCD times each of the terms and then just working it out, simplifying and working your way down to find the different AB or ABCD or whatever terms you actually have. All right, so any questions before I go?
Nope.
All right, well, I'll see you all tomorrow then.